I just want to welcome you all again to day 2 of week 5. Can you believe it? Day 2 of week 5, right? We're just a week closer to your exams, and it'll all be over. and But right now we have to get some work done, and so we're gonna start off with math as we always do from 6 to 8, and then we are going to move on to general science, then health science. All right. If you
Miss
haven't,
T, can we please do health first, Miss T? I had
no.
Miss T. For once, you always do general first when it's supposed to be out.
Um, if you haven't done so already, please place your present, send it to my WhatsApp number. Place here, send your present. Also, as we are moving forward, please send in the notes. Some of you are not sending in the notes. So please send in the notes for me as we move along. Okay, so we're gonna start off pretty easy, and then we're gonna go alternate between easy and hard and easy and hard like we did yesterday. Okay, so let's dive right into it. So the first question, write this down for me. It says, so we are on number 16. We finished yesterday. We finished 19. This graphing thing. We finished the the car payment thing, and we also did the time graph. Now today we're going to be looking at we're going to be beginning with this question number 16. And the reason why I start from the back is because the front is too easy, so I want to start at the back so that we could have a little something interesting to do. Okay, so number 16, it says 515.79. Sorry, 515.779. Write the above number correct to two significant figures. Write the above number correct to two significant figures. So the first question that I want to ask and answer is, what are significant figures? So here we have, they asking us to write it correct to two significant figures, but what do we mean by significant figures? How do we know when a number is significant? That's a question.
The numbers that don't include zero.
Numbers that don't include zero.
Can I sorry just popped in? What's the question?
What are significant figures?
Significant figures are whole numbers that when zero is not on zero is involved depending on where it is.
Okay. Okay, so all right, that's part of it. We have considered significant figures before. And what
Numbers that show the value.
Okay, numbers that show value. I like that. So this is a nice chart that really, provides a good summary of what we mean by significant figures, and I encourage you to copy this down. So if the zeros are at the beginning, we call them leading zeros. Right? If they're at the beginning, we call them leading zeros, and these zeros are not significant. Right? So we don't consider them to be significant figures or significant numbers if the zeros are at the beginning. Now, any non-zero number, once it's not zero, like say 2, 3, 4, 5, 6, 7, 8, 9, any non-zero number is significant. So for example, 3 and 7, these two numbers are significant because they are not zero. Okay? Now, there's a time when 0 could be significant. Now, 0 can only be significant when what?
It's in the
When
middle.
it's behind a whole number, 1, 2, 3, 4, 5. So
It's between.
When it's between a significant
Two
When
numbers.
when it's between two when it's after like a whole number.
When it's between
A significant
when
number.
it's between two significant figures, right? Just as in this case, right? So
Yes, sir.
so leading zeros are not significant, but if they are in between zeros are significant. All right. Then there's also a time when zeros could be significant, and that is the case when they are behind a significant number. So when they're in between and when they're behind, so we call them trailing zeros, they are significant. But we have to be careful with trailing zeros. Trailing zeros to the right of the decimal point are significant. That is to say, if we had, say, like a number like 700, if we had a number like 700, how much significant figures do we have?
2.
3.
3.
No, we only have one. All right, because even though we have these trailing zeros are not to the right of the decimal point. They are before. So these trailing zeros would not count. All right. The only time trailing zeros count is when we are behind the decimal point. Okay. So bear that in mind. Okay, so let's look at these examples. So in this example, we have 4 significant figures. Because 2 is a significant figure, why is 2 a significant figure?
Because it doesn't
It has
include
the
0.
leading zeros. No.
No.
It's greater than 0.
Because 2 is non-zero.
Non-zero.
Remember we
Right.
said that all non-zero numbers are significant?
Right.
So
Because it's non-zero.
So 2 is significant because it's not 0. So numbers like 1, 2, 3, 4, 5, 6, 7, 8, and 9,
Right.
they are automatically significant. Why is 6 significant?
Because it's
not zero.
Yeah, because it's a non-zero digit. Now, why is this 0 significant?
Because it's between 2 0.
Between two significant figures.
Yeah, very good. Yeah. Now, why is this 0 significant?
Because it's followed by a significant number.
It's trailing and it's behind the decimal point or to the right.
Very
of
good.
the
It's
decimal.
trailing and it's to the right of the decimal point. Okay. Okay, so here we have 5 significant figures. 4 is significant because it is non-zero. 1 is significant because it's non-zero. 0 is significant is because it's between 2 significant figures. 8 is significant because why?
It's non-zero. It's a non-zero number.
Very good. Now 0 is significant. Why?
Because it's
It's a
trailing
trailing zero and it's behind the decimal point.
Good, perfect. Now we have the number 70,900. It only has 3 significant figures. The 7 because it's non-zero, the 9 because it's non-zero, and the 0 here because it's in between.
In between.
Right.
Now, why are these 2 zeros not significant?
Because
it's not behind the decimal.
Very good, perfect. So that's a little overview of significant figures. So let me know when I'm able to move it, and then we can move on from there to get to the question. Remember that if you're here, please send here or present to my WhatsApp number. Can I move it?
Yes, sir.
Yes, sir.
All right, perfect. Okay, so all right, so let's go back to our question. So we are gonna write it correct to 2 significant figures. Okay, so let's place this here. All right, so we're looking at the number 515. How much significant figures do we have here?
So you want to use this significant figure if you like kind of rounding.
Yeah, we trying to round. I mean, usually when it comes to an exam, they ask it when it comes to rounding.
Miss Petit, when you say significant figures, you mean like the whole thing or just
The whole thing. How much significant figures?
6?
6?
6. Why?
Because they're non-zero
All of them are
numbers.
Yeah,
non-zero.
all of them are non-zero. So this is an easy one. This has 6 significant figures. Now, when we're talking about significant figures, though, someone is asking me to let them to join. Give me one moment. Someone's asking me to let them join. I'm trying to figure out. Okay, there we go. Now, when we're talking about significant figures, right? And we're talking about the first one. Which one would be the first one? Like, how do we count it?
5?
Is it the 5 or the 9?
5?
5.
Yeah, the 5 would be the first one.
5.
And then if 5 is the first one, which one is the second one?
1?
1. So they asked us to write it correct to 2 significant figures. So the first thing you have to look at is you have to look at the first one, which is 5. You have to look at the second one, which is 1.
Just 1.
So because they asked you to write it correct to 2 significant figures, this is the one that you're going to underline. So we're going to underline.
So we rounding it.
Yeah, we're rounding.
Oh,
Right?
okay.
So we're going to underline the number 1. All right? Now we're going to look at the number behind 1 and we're going to circle that number. Okay? And that number is
5.
5.
5.
And so we know if that number is number to the right of 1, if it's less than 5, we are going to round down. If it's greater than 5,
Gonna round up by 1.
yeah, if it's greater than 5, we are going to round up. And if this number is equal to 5, what do we do?
Still round up, right?
Yeah, you still round up. Okay, so if it's equal to 5, we still round up. So is 5 less than 5, greater than 5, or equal to 5?
Equal to 5.
Equal to 5.
Equal to 5. And so that means that we have to round
Up.
up.
1.
So that means we're going to add 1 to this. So add 1. And so that'll leave us with, this is going to be equal to 5, 2. And everything else becomes
0.
0. Everything else becomes 0. So all
You
them,
could draw in the zeros or no?
say it again?
You could draw in the zeros, or you could just leave it as 52.
Leave it as, no, you have to put in 520. Okay,
That's the answer.
that's your answer.
Okay.
520. Okay. And that's it right there. Okay. Any questions on it?
If you put 52, would it be wrong?
Definitely would be wrong. That would be way wrong. Because
Why would it be if it had
Why?
2? That's my question.
it would be hugely wrong. Because what they're trying to say is that they're trying to say, look at the spectrum, right? And they're trying to say, or look at this number line. And let's say we have 520. And let's say we have on the other side 510. And then we have in the middle or so 515. 515 point what? 7 what?
9.
Right? Now what they're really asking us, right? When they ask us to round this thing, is they're asking us, is 515 closer to 520 or is it closer to 510?
520. Oh,
5.
It's closer to 520.
20, yes. It's
So
15.
that's what the question actually is saying. Now, if you go ahead and put 52, they can say, is this person head right or what? Like, because they're asking you, is it between 520 and 510? You see what I'm saying? So if you go ahead and put 52, 52 is all the way, oh my goodness, I draw the number line backwards. But
Very backward.
yeah, I draw it backwards. Let's just pretend that positive is here and negative is here. So, but the idea is that 515 is closer to 520. You see what I'm saying? And so, no, sorry, 515.779 is closer to 520 than it's closer to 510. So therefore you can't put 52. You understand, Nancy?
Yeah, I just wanted to know because when it said two significant figures, I thought you just put the two first numbers and then round it.
Yeah, the two first numbers, when they say two significant figures, they just mean, hey, that's gonna be your indication. The first one, then the second one. Okay? But they
Oh,
don't mean that you only have two numbers. All right?
that's why I just get it wrong, I guess.
Yeah, yeah, probably. Um, Now let's look at the same number, but we're gonna do it to three significant figures. So I want us to consider 5, 1, 5.7, 7, 9, right? That's what it was.
Yes, sir.
And I want us to write it to three significant figures. Okay, what would that be? Oh, one moment. Let me allow this person to come in. So write that to three significant figures for me.
516.0.
Okay, so let's go back to our question. So yeah, so
516.
we want to write this. For those who are just joining, please place here or present, send it to me on the WhatsApp number. Okay, so we're trying to write this number to three significant figures, right? So which one will be our first significant figure?
5,
5.
5. The second significant figure would be 1.
1,
And then the third significant figure would be
5,
5. The first thing we do is underline. We underline 5. Okay. This is the
One
number.
circle 7.
This is the number that's under consideration. And then we circle number 7.
7,
Now it is clear that 7 is less than 5 or greater than 5.
greater than 5.
Greater than 5.
Good. So we round up or down?
Up.
We round up. So it's going to be plus 1. Okay. So it's actually 5/16. So 5,
Right.
1.
Point 0, right?
No, you just put 5/16.
What? Okay.
So how come we don't add a zero?
It doesn't
How
matter.
can I add the 0 plus 1?
It doesn't matter. Okay, 5/16.0. Is that different from 5/16?
No.
Ew.
No,
No.
it doesn't. It's just no difference.
Did you get it wrong? What's the added?
Would you get it wrong if you added? No, I don't see you getting it wrong if you added. They equal. They equal the same thing. You ain't getting it wrong.
But the 520, you would get wrong if you just put the 52. 'cause the
Yeah,
zero
definitely.
mark- Okay.
Mr. Petit, what if, right?
Yeah.
They don't want you to put 0.0 and they take that as 5/16 times 0.
Times 0. No, they wouldn't take that as times 0. They wouldn't take it as times 0 because there's a distinct way when you're doing multiplication. So multiplication is denoted as, if you would have denoted as multiplication, you would have put the point sort of like in the middle, as opposed to putting it below. So that's the
Right.
difference. You see what I'm saying? So they wouldn't consider it as multiplication unless you put the decimal point up in the middle there. Then yeah, they could consider it as multiplication. But if you have it down below L, they know what you mean. But keep it as a whole number. Don't write the .0 thing. All right.
I had a question, but it's unrelated to this.
Is it related to math at all?
Yeah, technically.
Oh boy. I wonder if I want to take this question.
No, it's just a yes or no question.
Okay, all right, go ahead.
Okay, like you see how we was talking about that 516 times 0 and how that examiner could take that. You
Yeah.
could like dispute your answers.
No, you can't. I mean, you won't be there when they marking it, so then like they can call you and say, "Hey, what this mean?" Or no. So once the script is from away from you,
But you can't dispute your grade if you get a grade low.
that's a good question.
But you don't.
I don't know. That's a good question. But the markers, they're rigorous though. I could be honest with you. They go through multiple examiners, like not just one person mark it, a couple persons mark it, and they review it, and so it's pretty rigorous. I don't know if they will even, you know, bother with a dispute. I don't know. I'm not certain. Never had that before. Never heard of someone who disputed something before, so I don't know. Um, okay. All right, so okay, so let's continue with the same question. Not this one yet. Okay, so now we wanted the two decimal places. Now, so this is very important. The two decimal places, they mean the two decimal places. Like, they mean that they wanted exactly the two decimal places. So you can't be putting, oh yeah, 3SF means three significant figures. I did that and I didn't even tell you that. 3SF means three significant figures. Thank you for that question. So the next thing is, we want to write it correct to two decimal places. Please master these type of questions. They always come. I don't know why they're in love with these type of questions, but writing it correct to two decimal places, significant figures, you know, they always come. So make sure you know how to do it properly. Okay? I can't emphasize that enough. So we want to write this 515.779 correct to two decimal places. And so let's do that. So we have 5. Please write this question down, especially for those who just arrived and trying to figure out what we would be doing. Write down this question for me and send in the working once you're finished. So we have 515.779 and we want to write it correct to two decimal places. Now, currently, how much decimal places this is written in?
1.
No.
3.
3.
3.
We have 1, 2, 3 decimal places and behind.
I think 3 was okay.
Say it again. No, someone
I
said
said 3.
no. Someone said 1.
Oh.
I said 1.
Yeah. So I was saying that it's 3 behind the 3 numbers behind the decimal point. 1, 2, and 3. So we want to cut it down to 2. Okay. So that means that we have to consider the 7. We're gonna underline it. All right. And then we're gonna circle which number?
9.
Number 9. Good. Let me ask ourselves: is 9 less than 5?
Greater.
Greater.
Is 9 equal to 5?
Greater.
Sorry, it's supposed to be 5. Is 9 equal to 5? Is 9 equal to 5? Or is 9 greater than 5? Now, obviously, 9 is definitely
Greater than 5.
greater than 5. And so we're going to round up, right? So we have to round up.
Yes. Yes.
And that means adding a 1. Okay? And so this is going to be equal to 515
7, 8.
point
7,
78.
8.
Good. Now, do we put 780?
No, sir.
Fine, sure.
No, sir.
No. Yes.
I think we do.
I mean, yeah, because you
No.
I think you ran
No.
it up.
Right.
I don't think so.
Why not?
I think.
You think so?
No, because it specifically said 2 decimal
Two,
places. We
two
just
decimal
established
places.
that there's a question of 3 decimal places. So if we
Exactly.
take off 1, that's 2.
Exactly. You couldn't said it more plainer, right? The question specifically said
2
two
decimal
decimal
places.
places. Okay? So don't go put no placeholder, 0 trying to be nice and cute, right? No. It says 2 decimal places, so we don't include that,
Okay.
right? Even though 515.780 is the same thing, technically speaking, from a values perspective, as 5.5, sorry, as 515.78. They're the same thing, but they specifically said 2
2
decimal places.
decimal.
So make sure I only put 2. So this is the answer right now. Any questions on that for me, please?
I don't know if this is a stupid question, but okay. You see how you said it when we said 2 decimal places, but
Yeah.
for number it just said 2 significant figures. So why we have 3 places there?
Okay, very good question. Because remember what we said, trailing zeros to the left of the decimal point are not significant figures. So
Oh,
yeah. So technically this only has 2 significant figures.
okay.
Yeah. Okay, math is easy, don't make it hard. Okay. Okay, so thank you for those questions though. Very much appreciated. It shows me that you're thinking. All right, send in those. Well, let's do this last one and then I'll ask you to send it. Let's do this last one. To the nearest whole number. To the nearest whole. What is a whole number, by the way? Let me hear these definitions for you. What is a whole
in
number?
front of the desk.
Whole number is
The
1, 2,
number
3,
in front
4,
of the
5,
desk.
6.
I want examples of whole number. I want the definition.
A whole number is a number.
Mm.
It's a number greater than
Integers?
0.
Is that a number? A
It's
number?
just a number? You
It's
sure?
it's
Just
a
a
number.
number.
It's not just a number, but
Any is
Number greater than 0.
Hey,
it's
isn't
a number.
it just integers?
Well, -5 is an integer. Is that a whole number?
Positive numbers greater than 0.
But how about 0?
Positive integers?
But 0 is a whole number too. So and 0 ain't positive.
uh, so numbers in front.
And numbers greater than -1.
A whole
Numbers
number is
greater than
simply
-1.
any
Oh,
positive number that doesn't include a decimal.
all right, write this definition down.
Natural count numbers.
Mr. T, really?
I know, right?
I don't. What you supposed to like say? What is like? How you supposed to explain what is a whole number?
All right.
Would it be positive integers?
Okay, whole numbers. There's different definitions, but this is the one I like. Whole numbers are numbers that are a part of the following infinite set. That is so we are defining a whole number in terms of set notation. So it's going to be 0, 1, 2, 3, 4, 5, and so on. They these are positive integers, including 0. They do not include fractions, decimals, negative numbers. Okay, that's what a whole number is. So whole numbers are gonna start from 0, go to 1, then 2, then 3, all the way up to infinity. So basically they are your positive integers, but not just your positive integers. They also include 0. Okay. Now there are no fractions as a whole number, and decimals are not considered whole numbers, and negative numbers are not considered to be whole numbers. Okay, so this is a working definition of whole numbers. Okay, are we good?
Yes.
Yes, sir.
Well, let me take this down, Mr. Bitty.
Okay, no problem.
Why we come here again?
Why we come here? What you mean?
On whole numbers.
Oh, because of we trying to write the numbers correct, whole number.
Okay, I'm done.
Good. All right.
Hold on, bless.
No problem.
I got it.
Okay, good. All right, so let's go back. Let's go here. So we want to write this to the nearest whole number. Notice that it is not a whole number, right? Why isn't this number 515.779 a whole number?
But it's a decimal.
Because it's a decimal.
It's a decimal.
It is a decimal, and it's actually a terminating decimal. That means that it has an end. It stops. And so we're gonna write this as a whole number. So we have 515.779. And so because we want to write it as a whole number, the number that would be under our consideration would be 5. Okay. And we're going to look at the number to the right of 5, which is 7. Now 7 is greater than 5, so we add 1 because we're rounding up. And so written correct to the nearest whole number, this would be
16.
16. Do we put 0.0?
No, sir.
No, sir.
No.
No. Why don't we put 0.0?
Nearest whole
Because that's
number.
the same thing as 5, 1, 5, 16. And
It wouldn't be a whole
nearest
number.
to
It wouldn't be a whole number. Okay. All right. So we want to be careful. Another way of writing the same question would be the same question is the same thing as saying we want to correct the 3 significant figures, right? That's another way that they could write this question.
Let's go.
Okay, so that's all parts of this question. So please send in question number, I think that was 16. So send in all the parts for me. Let me see what you're doing. If you're doing
Mr. Petit, doesn't it and technically have that anyway? Like, isn't it implied anyway?
what, the 3 significant figure? What you mean?
The decimal and the 0 after.
It's implied. I understand it's implied, but don't write it. Okay? You don't want to put no decimal.
Mr. Petit.
Anywhere. Just a straight up whole number. Go ahead, sir.
I have a question. Why did you add the 1 to the 5?
Because 7 is greater than 5. So
Yeah.
we round up. You understand?
All right. So once the number is greater, round up.
Yeah, once it's greater than 5 or equal to 5, you round up. But if
Okay.
it's less than 5, it
Leave it
stays
as
the
is.
same. Yeah, leave it as is. Okay. Thank you, Miss Reckley. Thank you, Miss Nixon. Thank you, Miss Cooper. Thank you, Miss Michaela. The rest of you, I'm still waiting.
But is it a real whole number though?
Pardon?
But is it a whole number? Does they really exist if the decimal and zero are implied anyway?
Okay, so when we say decimal, we mean fractional part. So when we have the point zero, right? Right? 0.000000. Yeah, technically that is a decimal, right? But when we say no decimals, we mean no fractional part. Like we mean like a real fraction, like something like 1/3 or 2/3 or 3/4, something like that. You see what I'm saying? So we mean, 0.000. That's what we mean. We mean like 0.01 or 0.324, stuff like that. You see what I'm saying?
Okay.
Yeah. So we're not talking about these simple decimals. Otherwise, no number would be whole, right?
Yeah, that's what I was thinking.
Yeah. Thank you, Mr. Juan. All right. Thank you, Mr. Dylan. Thank you, Ms. Raming, Mr. Adderley. Thank you, Michaela and Alicia Reckley. Thank you, Deshaun. All right. So
So when they
let's.
talk about whole numbers, don't they mean fractions?
What you
But
mean?
fractions ain't part of whole numbers.
No,
There's,
fractions are not a part of whole numbers. No.
but you get fractions as a whole.
What do you mean?
Whole fractions.
Give me an example.
Like 5/5 is a whole.
Yeah. Again, when we talking about no fractions, we're not talking about fractions which equal a whole. We're not talking about that. You see? We're talking about
Okay.
we're talking about the ones like the 7/3 or the 3/4 or those ones. Not the ones that equal a whole. Okay. All right. So that one is pretty easy. Nothing to it. Just a lot of, remembering and, understanding when to put the zero, when not to put the zero, understanding what we mean by significant figures, understanding what do we mean when we say two decimal points, two decimal places, what is a whole number, and those things. So please practice questions like these. You will see them again and again as we continue through these past papers. You'll see them again and again and again and again. They love these type. All right, so make sure you know how to do them properly. All right, so that was the easy part. Like I said, we alternated between easy and difficult. And so let's consider something that is probably a little more less familiar. I wouldn't say hard, just less familiar. Last class we did the first three, all right, and we saw how to factorize those ones. Today we're gonna consider B. So let's consider it.
We didn't finish them questions.
No, we didn't finish. We didn't finish them questions. We didn't. It took so long to do those three. I mean, I took up most of the time. So we didn't finish Miss Cooper. All right, so the general expression of a trinomial, and we said a trinomial is a polynomial with three terms. So term 1, term 2, and term 3. And they say the general expression for this trinomial is ax squared plus bx plus c. Now they say when a is 1 and c equals to 9, determine the value of b so that the product of the factors of the expression is the difference of squares. This is a very, I would say, on the scale of 1 to 10, this is like a 7, 8, you know what I mean? at least for a high school student, this is not a trivial question. This is one you have to really think about it. So let's do it. So we have to, they give us a equals to 1. They give us c equals to 9. And we have to fix it so that our product of factors is a difference of squares. All right, now, I don't know if you're familiar with difference of squares, but let me just explain difference of squares first before we, knock this out. Anyone know what we mean when we say difference of squares?
No, sir.
No, okay.
Subtract.
Okay, very good. Well, so let's just break it down. So difference of squares. So of course we know that difference means that implies subtraction. So we know that some subtraction is going to be going out. And of course we know that squares. Squares is what? Anything to the power of what?
Times itself. 2.
3.
Power of 2. Because it's a square. Okay?
Cube. And 3 is cube.
Right? So squares and difference. So when we talk about difference of squares, what we mean are the following types of questions, or the following types of expressions. So we'd have x squared minus 9. Now, why is that a difference of 2 squares? No. Let's not use 9 first. Let's use 4. Okay. So x squared minus 4. Why is that a difference of 2 squares?
Because
Because one is an x squared and one is a 9.
Because x is raised to the
you
power.
subtract.
And what
And you
times
subtract.
itself gives us 4?
2.
2. So this could be written as x squared minus 2 squared. So here we can see it's a difference of 1, 2 squares. You see that, right? It's a difference, subtraction, of 2 squares. This square and that square. So that's why we call it a difference of 2 squares. So when we say difference of 2 squares, these are the type of stuff that we're talking about. X squared minus something. So let's give me a next one. We could have x squared minus 9. And that's equals to x squared minus what?
3 squared.
9.
Squared.
3 squared.
Yes.
Yeah, we can have x squared minus
6.
16. So it's going to be x squared minus 4
8 squared.
squared. Then we have not 8 squared, it's 8 times 2 is 16. Not 8 times 8.
Yeah, my bad.
8 squared minus what? I mean x squared minus what?
20.
25.
25.
So it's going to be x squared minus 5 squared.
5 squared.
Okay.
Yeah. Now, with these sort of questions, the formula, right? The formula, and please write this formula down. You must know this formula. It's a formula that you need to know. So the formula tells us that this is a difference of squares formula. So this is the difference of squares formula. The difference of squares formula says that x squared minus a squared, where a represents a number, is going to be equal to, open bracket, x minus a, close bracket, open bracket, x plus a. Okay, that's what the formula says. That's the difference of squares formula. Okay, and you must know that. So they're basically saying that if you have something like this, x squared minus a number squared, you could write it as x minus a times x plus a. And this side, if we were to multiply this side out, you would see that it equals exactly this. Okay, so that's the formula. So that means that if we have something like x squared minus 4, so let's apply this formula. We have something like x squared minus 4. That's actually equal to x minus what?
2.
X minus 2. Close bracket. X what?
X plus 2.
X plus
Plus 2.
And if we have something like x squared minus 9, that's going to be equal to what?
X minus.
X squared.
X minus what?
3.
X minus 3.
X minus 3.
3.
X plus.
And then X plus 3.
X plus 3. Very good.
Okay.
And then if we have something like x squared minus 16, it's going to be equal to
X minus 4.
X
X minus 4. And then X plus 4.
Yeah. And then x squared.
So, Mr. Petit,
Yes, sir.
you still have to find the square root of the number first, right? To
Yeah.
put in this formula.
Exactly. So you have to find the square root of it first. I like that. I like that you noticed that. So x minus 5 and then x plus 5. So know this formula. Know how to apply this formula. Okay. Now these things mean something. So what happens is this quantity is multiplied by this quantity. And if we were to actually multiply it out, you would actually see that they equal the same thing, right? And let me multiply it out for you to see that like these two are actually the same thing. Like this is the shortcut way of doing it, but if we actually multiply this out, you would see that it equals exactly x squared minus 4. So let me do that. Let me multiply these two so you could see that it's exactly x squared minus 4. Just so that you could see it and so that you can also understand what these things mean. This quantity is multiplied by this quantity, and this quantity is multiplied by that quantity, and this quantity is multiplied by this quantity. Okay, so let's do it. Let me know when I can move this slide. Can I move it?
Mr. Petit.
Yes, sir.
Yes, sir.
Go ahead.
Maths for babies.
Maths for babies? Why you say that?
You got so much formula?
Oh, mercy. I wasn't expecting that one. Anyway.
Real.
Alright, I could use that one of these days. Okay. Alright, so let's do it. So let's actually multiply x. We're going to use the FOIL method. Anyone familiar with the FOIL method? Anyone? That's not true.
Yes.
Come on. That's not true. Y'all have to be familiar with the FOIL method. FOIL. Nancy?
Yes, sir.
You ain't familiar with the FOIL method?
Foil?
Yeah, FOIL.
I think I heard of it, but I don't know. I'm not familiar with the name.
Okay. So
Yeah.
the idea is that you multiply this term with that term. So we say x times x which is going to be equal to, what is x times x?
X squared.
X squared.
X squared.
All right, good.
I'm familiar with it. I just didn't know it was the FOIL method. Gee.
Then we say x times 2 is going to be equal to what?
Is it 2x?
2x, yes.
It's called the FOIL method.
Yeah, the FOIL method. FOIL.
I thought it was multiplying brackets,
Yeah.
Yeah, I never known the FOIL method.
And then we take the negative 2, multiply that by the x. Okay, so that'd be negative 2 times x is going to be what?
Negative 2x.
Negative 2x. And then we take this negative 2 and we multiply it by this positive 2. Gives us what? Gives us what?
0.
Negative 4.
Negative 4.
Negative 2 multiplied by positive
Oh, I
2
didn't
is...
say add, sorry. Negative 4.
Negative 4.
Yeah. So what is positive 2x minus 2x?
0.
Yeah, they cancel each other. So it's going to leave us with, it's going to be equal to x squared minus what?
4.
Wow.
Which is exactly what we saw with using the formula. Right?
So would you ever try to find what x squared is?
You're not solving the value of anything. You're just either expanding expressions or simplifying expressions. Okay, so you're not solving at this time. So x squared minus 4. Okay. So that's just to show you that the formula is telling the truth. Okay. And we could do the same thing for each one. We could do the same thing for x minus 3, x plus 3, x minus 4, x plus 4, same thing.
Well, I wasn't finished writing that previous one.
No problem.
Okay, I'm done.
Okay, good. So now let's go back to this question. Okay, so now let's consider these. So it says when a equals to 1, c equals to 9, determine the value of b so that the what? The product of factors of the expression is a difference of squares. So let's do that. So we trying to get a difference of squares, something that look like these things and these things. So let's do this. This is gonna be, oh wow, I hope this ain't that easy, man. I hope this ain't that easy. Okay, so it's gonna be ax squared plus bx. This is the general form for trinomial, and this is actually the general form of a quadratic expression, because the highest power of x is 2. Now a equals to 1. That. So a equals to 1, so we're gonna put 1 here, and c equals to negative
9.
I'm gonna put negative 9 in place of c, and then the rest we have nothing to substitute, so we leave it as is. So it's just gonna be x squared plus, oh my, Why do they do this in the exam? A whole national exam.
So you want to be at?
It's too easy. I don't know why they do this. I thought it was gonna be, you know, I thought it was gonna be complicated, but it's too easy. Y'all can figure this out in a heartbeat. So this is equal sign. So it is gonna be x squared plus bx plus -9. So 1 times x squared is what?
X squared.
X squared. All right. Plus bx, right?
Yes, sir.
What is plus times negative? What is plus times negative? What is that?
Negative.
Negative 9. Now I want you to think with me. What must B, what must the letter B be equal to such that we could get something looking like one of these? What must B be in order for us to get something looking like one of these?
Is it 3?
Squared.
3.
No. If B is 3, we'll have x squared plus 3x minus 9. That wouldn't be good.
What?
So yeah,
Even if it's squared.
even if it's squared. No, it still wouldn't work.
Would it be 9?
No. If you have x squared plus
1.
9x, that wouldn't work. What if, right? So let's say if, and y'all got smile when y'all see this. But if b equals to 0, then what will happen? Then x squared, continuing, right? Then x squared plus bx minus 9 is going to be equal to, remember b is 0, so it's going to be equal to x squared plus 0x minus 9. Now what is 0 times x? What is 0 times x?
0.
0. So do we need to write the 0?
X.
What is 0 times x?
0.
0.
0.
So we don't need to write it, right?
No.
So
No.
what are we left with? X squared minus 9.
Minus 9.
Now you may be thinking, what about this plus? But plus and negative is still negative.
Negative.
So we left with what? X squared minus
Minus 9.
9. What is x squared minus 9? We just saw that.
X minus
X minus 3.
3.
Yeah.
And then X
And then
plus 3.
X plus 3.
Plus 3.
Yeah. Good. Okay. So the value of b that would make this expression a difference of squares is going to be 0. Oh my, oh my, oh my. This is too easy. Okay, so I dropped the ratings. This is actually it's not a 7. It's actually a 1. It's too easy. But go ahead.
That was not easy.
All you have
How
to
would
do is
you how would you assume that B is 0?
how did I know that b is gonna be 0?
Yeah, so
Well, they say determine the value of b. So this is what we have to figure out. And you could clearly see it would have been 0 because look at this. I don't know how y'all didn't see it. X squared minus 9. Like, clearly we have the x squared. Clearly, we have the minus 9. The only problem was the bx, so we just need to move that. How could you move it? If you multiply x by 1, it'll be wrong because it's still have x there. You want to move this entire term. The only way you can move this entire term is if you multiply if this b is a 0. And if this b is a 0, then 0 times x is 0. So this whole term would go. And so we are left with simply x squared minus 9.
Okay, thanks.
You understand what I'm saying?
Yes, sir.
So once it's like that, we automatically know that it would be 0 for any.
Yeah,
yeah.
you know it's gonna be 0 because you want to get rid of this. This is the problem. How you can get rid of it? Well, b have to be 0. I mean, choose any other number for b, then it'll be a problem because if you choose 3, it'll be 3x minus 9. And that's clearly not one of these, right? If you choose b to be 4, it'll be x squared plus 4x minus 9, and that's none of these. So the only thing we need to do is we have to move this bx. And we only could move it. We only could, get rid of it if b is 0. Okay, so that's the idea.
Mr. Petit, I have a question, but I think it's going to sound a little odd.
Go ahead.
But you see how we factorize it, like when you, like how we did yesterday and today, I'm maxing, like, is that how we factorize for like every single thing? Like when they give us a question where we have to when they just say factorize, would we have to do it like exactly in brackets, like how you have it? Is that how we're supposed to factorize?
Which one you talking about?
Okay, like how these questions we're factorizing and then we're putting them in brackets. Like,
you mean for this one?
Yeah, and for the ones we did yesterday, is that how we're supposed to factorize
you have to,
entirely?
Yeah. That's how you factorize. Just like how I have it, it's just how it's supposed to be, yes.
Also, like all the BGCSE questions that we've been doing, we were supposed to like factorize them in brackets then.
Yeah.
Wow, I didn't know that.
Okay. Well, that's what you're for, right? To learn. So, yeah, that's what factorizing means. Factorizing means that you grouping them. You're trying to write it in a more compact way, right? So yeah. Okay, so right, so let's consider okay, so let's go back to our easy peasy questions. This one was unfamiliar. I don't want to give too much unfamiliar things in one night. Okay, so let's go back to the easy ones.
That was it?
Yeah, that's it. That's all we had to do for that question.
That's me thinking you were about to do the full method or something. I thought you
That's what
continue.
I'm saying. This one is, yeah, I mean, all we had to do is substitute 0 and show that it turned in the difference of two squares, and it's good. Okay. All right, so let's consider geometry. Yeah. Our favorite, right?
Your favorite.
Okay, so the only issue with this question is that we do not have a I don't have the actual paper, so I'll have to draw my own triangle and show you how you would do it if this question would have come up. So it wouldn't be to scale. What I mean is that because I'm not using their triangle and I'm gonna make up my own, it wouldn't be to scale. Like for example, where it's imagine right down the length of whatever. But if you print this out, if you were to print out, this is 2021. If you were to print this out and actually do it, then you would get the precise measurements. All right, so okay, so let's do this. This is going to be. I'm just gonna do it so you can get a sense of How are you supposed to go about that? Okay, so make sure if you're not speaking that your mic is muted. So our triangle looks something sort of like this. It was something like that, and then something like that, and then something like that, isn't it? So we had P, R, and Q. So P, R, and Q. Okay, and so the first thing that they said is use a compass and ruler only to bisect angle P. So here we have P, and this is the angle P right now, and we want to bisect that angle. Okay, we want to bisect that angle. Okay, so the first thing we do, we get our compass, and bisect means to cut it in the middle. So we get our compass. We do it not too wide. We don't want to do it all the way out there. We're gonna do it, I would say, do it like, say, give it like about half the line or a little less than half the line. Lock it in, and then draw the arc. Okay, draw the arc. Good. So you already draw the first
You're
one.
drawing this also?
Yeah, you're drawing this also. This is not decorations. Look pretty, no.
Let's just say you can't do it all the way out showing my shape.
Do it over again. What were you doing when I was doing it?
Drawing my shape.
Watching Netflix, that's what you said? That's what I thought you said.
No, I was drawing my shape. I serious.
You sure?
Yes, sir.
So what I did was, I considered angle P, and I took my compass, and I drew an arc, starting from here all the way around, right? That's the first thing I
So
did.
why do you have to have it?
I was telling them that it shouldn't be no more than half. So make it half the line PQ, or make it a little less than half, but not more than half. So it's not like a precise thing, you're just basically eyeballing it. And so, but the thing is, you go to this point right here, where the arc and the line segment PR intersect, and you draw a arc right here. Alright, notice that my compass is the same length. I haven't moved it. Then I would go to the point where PQ intersects with the arc, and I draw another arc right there. Okay, and then I would go right here, consider where those two arcs intersect.
Mr. Petit. That third line you draw, how you do that one?
Okay, so the first one, I would go here, right? And I drew my arc. Okay, that's the first one. The second one, I went to the other side, and I drew my arc. Okay, is that clear?
Yes, sir.
And then I'll draw a line that starts from where this arc intersects, and that extends all the way to this point here, and then boom, it's bisected. Now we have to see. Let's measure this thing, and we hope that we bisected it properly. So the length of this angle is, let's measure it. The length of this angle is going to be, what's the length of this angle? Someone with good eyes. We start at 0. Okay, let me fix the protractor. Sorry, let me fix the protractor a bit. Yeah, I don't think my protractor is in the center. Okay, my protractor is, okay, we're good now. Alright, so yeah, it's pretty good. Look, The length of this, let me print screen this so you can see what's happening. So here, right? The length of the angle P is this. So that's the length of the angle P, the one that I'm encircling in red. All right. And if you look carefully, that's about, say, 65. It's about 65, right? So this angle right here, the one that's in red, is the angle P. And so all of this angle is angle P. And so this is about, this is 0, this is 10, this is 20, 30, 30, 40, 50, 60. So it's basically about 65, right? About 65.
Yes, sir.
And so when we
Okay,
bisect,
sorry, quick question. Which line did you put your geometry, like when you lay it down? Which line did you line it up with?
okay, so let's go back. Thingy. So if we go back here, what I did was I took this compass and I put it here, and I drew the R. And I took the compass here and I drew the R. Okay. And then I took this point in the middle and connected it to this point P. You see that?
I'm thinking, your compass part. I got that part. I mean, like when you put your compass on the angle. I mean, yeah.
My
How do you line
protractor,
it up?
my protractor
Sorry, your protractor. I saying compass. Your protractor. Sorry,
at P.
you lined it up with P.
It with P, yeah.
Oh, okay. I just
Notice,
wanted to make sure.
yeah. Notice how it's placed onto it. Okay, like that. So I ensure that the base of my protractor is on this side of the triangle, like so, and it's at a slant, and the center is at the point P. Are we clear?
Yes, sir. Thank you.
Yes, sir.
Okay, so we said that our angle is about 65 degrees. What is half of 65 degrees? Half of 65.
30,
32.5.
32,
yeah,
right?
32.5.
So if you look carefully, right, at if we look at if we look at if we look at if we look at this the angle, we call this our bisector, angle B. I mean this blue line right there in the middle. This is our bisector. Why do we call it the bisector?
It's the angle in half.
It cuts it in half.
It cuts the angle in half. And do we see that this cuts the angle in half? Because
Yes.
this is 0, this is 10, this is 20, this is 30, this is about 32, right?
About
Give or
32.
take, about 32. Okay, so we did it right. All right, so there we go. So please ensure that you know how to bisect your angles. They like to bring stuff like that. All right. Any questions on this? You're rather quiet. And when you're quiet,
So
go ahead.
I didn't get the same number as you. Does that make my one wrong?
No, remember I did it freehand.
Oh,
When
I want to say mine's is 16.
yeah, I did mine freehand, so obviously it won't be the same. But whatever it is, whatever your angle is, it must be half of it. So if this is 16, then half of 16 would be 8. Okay, and if this is 25, then you know what's half of 25 and so on. Okay, so make sure it's half of it. Okay, so the next thing that they tell us to do is after we already use a compass and to bisect the angle P, after we already bisect this angle, the next thing that they want us to do is let the bisector of P meet QR at X. Okay, where's QR? QR.
It's on top.
That's this line segment.
Yeah.
Yeah.
So they're saying that they want the bisector. Remember the bisector is the one that cuts P. They wanted the bisector to touch the line segment QR. Okay. So if we go to our construction thing, where does our bisector touch QR? Right there, right?
Yes, sir.
So let me let's make a big note of that.
Mr. Petit, what the question was so I could write it?
Yeah, I come back to the question. So this is where our bisector touches, right? At this red point. And what did they tell us to label it as?
Or Q?
No, they tell us to label it as
X.
As X. Okay.
Oh, I didn't know the question.
Okay, so let the bisector of P meet at QR at X. Okay, and so this is the bisector. This line, let me just make a note of that. This line is the bisector. And it meets at the point X.
I was repeat if that's the bisector, where's the bisectee?
Oh my goodness.
Oh.
There's no bisecting. It's only bisector. I guess if we wanna be technical, we would say the angle is the bisectee, since it is the one that is being bisected, but there's no such thing. Just bisector. Okay, so alright, so I want to see these diagrams, ugly or pretty. Let me see what you're doing.
But could you quickly go to the questions so I could write them down?
Yeah. And then the last question says to measure and write down the length of QX. Obviously the length of QX is going to be different for each and every one of us because we did it freehand, but I just want to show you what QX is. QX is the line segment QX. So that's I'm gonna denote that in blue. QX is gonna be this. So they want us to measure and write down the length of this line, the blue line. So let's use our ruler. Okay, so if I use my ruler to measure this, so this is gonna be about how much centimeters? This is about 3 centimeters, give or take.
Yes, sir. 3.
I mean, it's a bit more than 3, but we'll just say 3 centimeters. So here it's about 3 centimeters. Alright, and so that's what it is. Thank you, Miss Cooper. Anyone else? I really want to see your geometry part. Now, how do we know it's 3 centimeters? Notice that clearly this is 0, this is 1, this is 2, and this is 3. Exactly where that dot is. It's really, if I were to be very honest, it would be more like 3.2. 3.2 more so. But because we want a round number, I just don't want to be complicated. But it's really like 3.2. Okay. So let's go back to the question. So the answer is 3 centimeters. Let me just take a picture of this and put it here for record keeping. All right, so it's going to be all right, I think we're good.
I finished write down the questions.
Okay, no problem. Take them down, take them down. How is it already 7:24? How? Okay, everyone, don't worry. The time on my computer is not working properly. So what I really supposed to say is 6:24.
Your time is correct. Mine's the same time.
No, apparently there's a glitch in the system, and
Interesting.
Mr. Petite, this glitch is
Your
not
stop
global.
is 1 minute late because when I went to
No.
7:25, yours is just do 7:24.
wow.
Miss Petite, really gonna keep us back? Lord, give me strength. No.
Okay. Yeah, don't worry about this time. This is totally wrong. It does that sometime, you see. I don't know. It has a mind of its own. All
Sound
right.
like a government entity. There's always a glitch in the system.
There's always a glitch. Ah, boy. Hey, what do you say? If you have no excuse, right? Just it's a glitch in the system. Ah, all right. I know them banks. They like the bastard boy. They love that line, boy. The system has a glitch. The system is down.
You probably get that from there.
I guess no, mine. I don't think there's a glitch. Did I say there's a glitch? I did say there's a glitch. Yeah, this
You sure did.
This time is arc up, you know. I don't know why it does that. It's really supposed to say 6:26. Don't mind that.
Yeah, I know.
Yeah. Okay, the general expression. So let's go back to these type of questions. It says the general expression for a trinomial is ax squared plus bx plus c when a equals to 1 and b equals to 8. Determine the value of c so that the expression factorizes into a perfect square. All right, so we have to determine what we mean by perfect square. Okay, so let me show you what we mean by perfect square. So perfect. Anyone have any idea? Let me say perfect square.
What do you mean, like 16?
Nah, no, not that. That type of perfect square. So we mean perfect square means like if we have something like x plus 1. Let's say we have x plus 1. All squared. That's a perfect square because that's equal to x plus 1 times what? X plus 1.
X plus 1.
Yeah. And then we can also have x minus 1 all squared. Sorry. So x minus 1 all squared. So this is what I mean when they say perfect square. Something looking like this. X plus 1 all squared, or x minus 1 all squared, that's going to be x minus 1 times x minus 1. I haven't seen much notes from people on this one. What's happening? Very good, Miss Raming. Very good. I like that drawing. So x minus 1. And then it's going to be, we can do x plus 2 all squared equals 2. It's going to be
X plus 2.
x plus 2. Now, how is this different from difference of two squares? What's the
You would
difference?
have, it would have been x squared and plus 2. And it would have been x plus 2 and then x minus 2.
You want adding and subtracted.
Exactly, and then adding and subtracting. So with the difference of two squares, it's going to be x plus 2x minus 2 or x plus 3x minus 3. But here it's the exact same term, okay? So that's what we mean there. So this is going to be x, we could use minus 2 all squared. It's going to be equal to x. Finish it for me.
Minus 2.
No, in your actual notes.
Oh. Oh, you want to see it?
Yeah, I want to see it. Thank you, Ms. Cooper.
Mm-hmm.
Okay, so it's going to be equal to x minus 2 x plus 2. Now there is a, like Mr. Bethel said, oh sorry, I'm doing this wrong. Like Mr. Bethel said, you know, math, we always have a formula. So there is a formula for perfect squares. And of course, this formula you have to remember by heart. Okay, you have to remember it by heart. So the formula for perfect squares, so this is the formula for perfect squares. And using this formula, we can skip all of the multiplying, and we just could directly use the formula. Now what the formula says that, hey, if you have x plus a, and here a is a number, any number, and you want to raise that to the power of 2, that's going to be equal to x squared plus 2 open plus 2 ax plus a squared. Alright, so that's the formula for perfect squares. So x squared plus 2 ax plus a squared.
I'm sorry, can you explain how you got that, please?
It's just a formula. There's no explanation.
Oh,
It's a
So,
formula. It's a formula you should know. Now we
so
can,
you're saying A is a number, right?
a is a number, yeah.
So it'd be 2 a number and then x, or 2a x.
Goo. Just the petite. How much this math? Just like you just insert a formula and that's it, and put it.
No, I mean,
and let's put in the variables.
No, I mean there we have to prove the formula. I mean, so we could there's a way that and of course at your level we don't prove why this is the case, why this always work. But we could prove it. But that's not our work for this one. At this level, just know that someone proved that it works all the time, and then we just use it. Okay.
It's not enough regrets now.
Well, what regrets for what?
The exam.
No, you don't have regrets. Yes, ma'am.
So like I have two A and then X. You could put 2X and then A
2x and then a. What you mean?
in the middle.
Okay, so yeah, like how this up, let's say all this is 2ax. You could put 2xa. That could be right because they just but you want to keep the x at the back. That's just how it usually is. Now,
Okay.
the next thing is that if we have open bracket x minus a, so remember it could be positive or it could be negative. So it's gonna be x minus a squared. It's gonna be equal to x squared. It's the same x squared, but this time it's gonna be minus.
Minus. So it's the same thing, you just put the minus sign.
The same thing, just put the minus sign. Ax plus a squared. And so let's do an example. And so let's say, for example, we wanted to do this one. So we have x plus 2 raised to the power of 2. So that's going to be equal to, what's the first thing that we write? X squared.
X squared.
Good. Plus, what does the formula tell us to write?
2.
Good. What is a? A is
2.
2.
Number now. And then x remains by itself, so it's going to be x. Plus, what is a?
2.
A is 2, so it's going to be 2 squared. And so it's going to be equal to x squared. Yes, ma'am?
Could you explain that, but just why we're not okay? I don't understand, but okay, no. Is that from the beginning, please?
Okay, so we have x plus 2, right? So we comparing this with this. So in this case, the x is the x, and the a is the 2. You see that? And so.
Oh, okay.
Yeah.
I see it now. Sorry,
And so then we'll have x squared. This will just be x squared. Plus, the formula says 2, so we just write 2. But a is 2. Based on this question, based on this number here, a is 2. And so we put the 2 here, and then x we just keep that there. Plus a squared. Now remember, a is 2. So it's going to be 2 squared. And then next we say it's going to be plus, what is 2 times 2?
4.
4f. Plus, what is 2 squared?
4.
4. Good. All right. And so that's how we do this. This is the way. Now we could do it negative. If this is negative, the only thing that would change is what?
The sign.
The sign, right? It will be a negative sign instead of a positive sign. All right.
So we just have to run around with 50 formulas in our head at all times.
Well,
not so, because I believe that I think that in this exam they gave you the formula. So let me check. I think they did give you the formula. Let's see.
Mr. Badi,
Yes, sir.
how would we attempt that question with the circle and triangle?
We come into that, eh? Isn't that a part of the paper? So we are number 13. After number 13, I'm going to number 12. After number 12, I'm going to number 11. After number 11, I'm going to number 10. After number 10, I'm going to number 9. After number 9, I'm going to number 8. After number 8, I'm going to number 7. After number 7, I'm going to number 6. After number 6, I'm going to number 5. After number 5, I'm going to
Keep
number
going, please.
and all the way up to number 1. So we come at this. It's in sequence. So yeah, so they kind of help you, right? But yeah, you just have to memorize those ones because they don't have it there. Sorry about that. Okay, yeah. Yeah, you just have to memorize that. Okay, so yeah, so this is it. So let's go and actually do the question. It says
Go back just one couple seconds, please.
This.
Okay, I'm done.
I'm done too. With maths.
It's only a little formula. That's all it is. Just a little formula. That's all.
Yeah, let's beat it. It's just one little formula.
Just one little. That's one little formula. You was the one who doing physics and chem. That's way out of
Well,
math.
okay. Now you see why he said just one little actual formula.
You was the one who doing physics and chem. All right. And trust me, I'd rather do maths any day before I do them stuff. All right, so when A is equal to 1, B is equal to 8, determine the value of C. So this question factorizes into a perfect square. But usually these stuff are so easy though. Watch, let me just show you. Then they don't be complicated at all. One thing I can respect the BGCSE for that. And the BJC, they really they don't go hard on you. You know, they really just ask the very like the easiest kind of question that could come is the one that they bring. They don't really try to, damage you at all. The only way you won't get it right is if you don't know the concept at all. If you don't know the concept, then they could do. But if you know the concept, you've been exposed to it, and you know how to do it from an introductory standpoint, yeah, the questions don't be much harder than that. So we know that A is supposed to be 1, but only thing, what usually kills a lot of students is they lack confidence. So they enter the exam, oh, this gonna be hard, this gonna be hard, this gonna be hard, this gonna be hard, this gonna be hard. And questions that they could have done well in, they end up failing it because they thought it was gonna be hard. All right, so B equals to 8.
8.
Yeah. And then there's none to substitute for X. And then we just have to put plus C. We don't know what C is yet. So it's gonna be equal to 1 times X squared is just gonna be what?
X squared.
X squared.
Plus 8x plus C. Okay.
Mr. P, you could just try to get the marks from the working, right?
Say it again.
Like you could just try to get the marks from doing the working, right?
Yeah. Yes. Okay. Yeah. So what I'll do, right, is I'll compare this because this is 8, right? I would compare this to our formula. Remember, our formula says that we have once we have it as x squared plus 2 times a number times x, then it's going to be plus the squared of that number, so a squared So the way how we gotta do this is that we have to pull out a 2 from here. So we have to consider this is so listen carefully, this is very easy. Remember, we have to pull out a 2. Okay, the formula says that we need a 2. Okay, so we're basically trying to make this and this look the same. That's the idea. Okay, and so if we try to make them look the same, well, we know that we have a 2 here, and but we have an x squared here, and we have an x squared here, so that's good. But here we have 8x, and here we have 2ax, and so we have to pull out a 2. So if we pull out a 2, it's gonna be equal to x squared. If we pull out a 2, what times 2 gives us 8?
4.
4.
It's gonna be 2.
4.
Times what?
4.
4. Open bracket. X plus C. I want you to think though. Let's look at this. This is x squared. This is x squared. This is 2. This is 2. This is x. This is x. What is the value of a?
1.
No. Again, this is x squared. This is x squared. This is 2. This is 2.
What are the BC?
No, this is x. This is
C
x.
squared.
What is the value of a? Remember,
2.
a comes
8.
between a
Will
comes
be 8.
between 2 and x. Let's look at this. What number comes between 2 and x?
4.
4.
4, right? So this is telling us that a is going to be equal to
4.
4. So it's saying that a equals to 4. And so if a equals to 4, think about this now. What must c be in order to correlate with this a squared?
3, 4.
No,
2?
8.
no. C
It
must
will be
be
2?
a squared.
8.
6.
A squared. What is a squared?
So it'll be 4 to the 4 squared?
4 squared, yes. Which is going to be equal to 16.
Oh, wow. Oh.
All right.
Mm.
And so we say if C, that's what they asked for, right? The value of C, right? So if C equals 16, then we have the following. Then we'll have x squared plus 2 open bracket 4x plus 16, and using the formula we know that this is going to be equal to open bracket x plus 4 x plus 4 which is going to be equal to x plus 4 all squared. And we do that because of the formula. Okay, so that's how we would do that. Any questions for me on that?
Why you put the square to the end?
Because remember, if we have x plus 4 times x plus 4, that's x plus
Oh,
4 squared. Yeah. And we have to show that it factorizes into a perfect square. Okay, so we have to show that it's a perfect square. So here we show that it's a perfect square. Y'all sound very quiet, and usually when y'all quiet, that ain't a good sign.
Elizabeth, I
Watching the clock.
understand, but I just think practice would help. Cause
Practice, yeah.
I'm not familiar with this kind of teaching, I guess.
Okay. Yeah, so it's unfamiliar territory, so I understand that. So that means definitely practice would help. Okay, so that was number 13. So let's go back to the easy peasy questions. Hopefully it's oh my, I didn't even take the attendance. Who does that? Okay. Okay, good. All right, so Kennedy, you miss all the easy stuff.
Yeah. Practice, you see.
I just put in your leg. Okay. Okay. Okay, so I know some of you might not understand exactly what we just did. I know it's kind of difficult. But over time, as we do more of them, you'll understand. I don't expect you to understand everything in one go. It's new. To really understand it, you'll need to do like a bunch of exercises. You know, about 12 hours worth of exercises. And we only have 3 hours here. So that's an impossibility. But so I just introducing you to it for now. And then as we move on with other ones, you will get used to doing it. Okay. So let's turn to our easy exercises. Here we're looking at mode. So it said that the weight of 6 boxes is recorded below. So this is 75, 85 grams, 92 grams, 56, 75, 83, and 87. And so the question is, determine the modal weight of the boxes. So what is the mode? When we say mode,
75.
but what is the mode even before we talk about that?
Number that cause frequent.
Who comes the most? The number that comes about the most?
Frequent number.
Yes. It is the value in the data set that is the most popular. Okay. Or the one that occurs.
Well, what if you have more than one?
You could have more than one, and if you have two modes, we say it's a bimodal, so the data set is bimodal. If you have 3 modes, we say the data set is trimodal, and so on. So you could have more than one. But usually for these sort of stuff, they usually try to keep it at 1. Like I say, the BJC tried to, and the BGCSE tries to be nice to you all. Okay, so 75 occurs how much times?
2
Twice.
times.
And every other number occurs once, right?
Yeah.
So 75 is the modal weight. Let me write that down. So the modal weight is 75. All right, so straightforward. Like I say, math is easy. You want to make it hard.
So when does it get easy?
This is it right there. This is the easy stuff. And we just finished doing it. All right.
Mr. Bate, can you go back up for me, please?
No problem. So the mode is the most frequent value in the data set, the one that occurs the most. 75 occurs the most, so we have that there. The next thing that they want is the range. Anyone know what the range is?
It's when you
The largest,
subtract the
subtract the
largest
smallest number.
Yeah, the largest from the smallest.
Subtract.
So that's the range. So calculate the the range. So the range is going to be equal to the largest value minus the smallest value, and so the range is going to be equal to, what's the largest value?
82.
85.
92.
Which is 92.
92 grams.
92 minus the smallest
56.
56. What is 92 minus 56?
36.
36.
Mr. Isaac,
Yes, sir.
I did something similar. Wait, we had this for test today. Like this exactly we're doing.
This exact question?
Yeah, I think I know all this now. One second.
Wow, this is crazy. All right, that's good. All right, so the range is largest minus smallest, 36 grams. So next up we have we want the median. And what is the median?
83.
The middle number.
The
Middle
median
number.
is the median is
Middle.
the middle number. Okay.
I gotta read it for
You have a
grade.
range from
Oh
small.
yeah. You
Yeah.
got the
You have to range it from least to greatest.
answer is 83.
You think so?
On my
You
right.
range it from greatest to least.
Say it again.
I say, what if you do it the opposite way?
I've never done it the opposite way, and I'm not sure if that's right. Okay.
Yeah,
So,
what?
okay, so
I mean, in terms of you getting the median.
like I don't know if it was still a. Okay, so 56. My next number would be 83, right? No, 70.
75. And 83.
So do you still put 75 twice?
You have to put 75 twice.
Okay.
Then we have 83.
83. 85.
83, 85.
It's 83.
So it is
87, 92.
And 87.
Yes, and then 92.
And then 92.
Would be 83.
83 grams.
Okay, so the way how we do this is this number connects with
72.
75 connects with
87.
And 75 connects with 85, leaving us with the middle number as 83. So the median weight the boxes.
And where would you use these stuff?
So this statisticians do these things. 83 grams. And sometimes the median could mean something significant. Something more than just being the middle number. Sometimes the middle number has a certain significance to it. And so when they apply these, here we just learning the raw mathematics. When we apply these stuff to physics and economics and biology and the different sciences, we could attach different significance to what we mean by the median and what is the mode, what does that actually mean in the context of the specific subject. So yeah, that's how it works. For persons who are going to do higher, we're going to extend, we're going to do higher than just the basics. They can use these sort of stuff, especially in statistics. Okay, so
What do you mean statistics, BGCSE?
No, I mean statistics. Statistics in terms of I meant like the actual job of being a statistician, like that. They use these stuff a lot. So the average weight. So of course the average, or what's another word for average?
The mean.
Mean.
Yeah.
Okay. So that's gonna be equal to, what's the first thing we do? What the first thing we do? We're gonna
We
do.
add everything together.
Yeah, add everything together.
Add
And then we
everything.
divide it by what?
The amount of
Yeah.
numbers.
Yeah, the numbers that you have. So it's gonna be,
Which is 79.
so that's how much data values we have? 1, 2, 3, 4, 5, 6, and 7.
7.
7, and then it's gonna be 75 grams plus 85 grams plus 92 grams plus 56 grams plus 75 grams plus 83 grams plus 87 grams. Okay, and of course we want to show that we're gonna add first. And so that means we are going to get, this is gonna be equal to, what's the number, what's the value?
553, 553
grams, which is gonna be equal to what?
79.
79 grams. Okay, and that's how we do it. Very, very simple. Okay, what else we have here? That's it? Wow.
Yes.
Okay. All right, so that brings us to the end. Sadly. That brings us to the end of our mathematics discussion for tonight.
Post answer again, Mr. Petit.
Let me put it back again. The answer is 79 grams. So send me please the mathematics notes. And I hope that you learned something tonight. That you could carry on and build on, especially for the factorization thing. Of course, we need to see more questions like those so we can get more practice. These stuff like mean and median, and these stuff should be more like review. The geometry, please be familiar with the geometry questions. Make sure you know how to bisect and how to measure angles and stuff like that. Any questions for me before we move on?
Oh yeah, Mr. BT. Yesterday, when we were doing the sets, that was on our quiz. I don't know if you remember.
We was doing sets yesterday.
Yeah. So, no, never mind. It was on the 2nd of February.
Okay. How did you do on the quiz?
I passed.
Okay. All
With
right.
100.
For real?
Not for real.
Oh, okay. Not for real. All right. Okay, so, all right. Any other questions before we move on to health science? Sorry, the general science. No other questions? All right. Well, have a good night for those who are not doing these subjects. And I'll see you on tomorrow, which is Wednesday. I can't believe how it's already gonna be Wednesday tomorrow. That's crazy.
Yes.
I don't know. At any rate, have a wonderful night.
Alrighty. Night.
Sweet dreams and all that good stuff.
Okay. You guys enjoy.
Yes, definitely. They have fun. They love these stuff.
Okay.
All right. So, okay. So the last time we were here, we were talking about the different laboratory apparatus, that a person could use to. We're talking about the different laboratory apparatus that a person could use to work in the lab. Okay. And so some of the laboratory apparatus that we was talking about last time, anyone can remember? What are some of the laboratory apparatus that we was talking about last time?
Beaker. Graduated cylinder.
Yes. Conical
Test
flask.
tube.
Yeah.
Distillation flask.
I don't know if we talk about that, but that is one. The filter funnel. The dropper. All those are
measuring cylinder.
Yeah, measuring cylinder. Excuse me. All those are different sort of laboratory.
Thermometer.
Thermometer. We talked about thermometer. No, we didn't talk about thermometer last time. What I want to do today is I want us to look at so we talk about the lab, equipment. I want us to look at certain laboratory rules. All right, lab safety rules. That you need to bear in mind when you're working in the lab. All right, what things are appropriate, what things are not appropriate to do. So that's gonna be our discussion today. So let's head up properly. Today is Tuesday, the 8th, the 8th of February, the beautiful month of February. It's gonna be general science, and the topic is laboratory safety rules.
You going anywhere?
Laboratory safety rules. Okay, so let's begin with this. So what are some laboratory safety rules that you could remember offhand?
If you have long hair, always put it in a ponytail while doing experiments.
Yeah, what's the rationale behind that though?
So you don't catch your hair on fire.
Exactly. All right. Any other laboratory safety rules that you could think of?
Always wear gloves when mixing chemicals.
Say it again.
Wear goggles.
Wear goggles. Yes. Wear gloves.
Always wear gloves when mixing chemicals.
Yeah.
No playing.
Don't run a laboratory.
No playing. Exactly. No playing in the lab. Okay. So the first rule that I want to talk about is, this might seem straightforward, but it's actually true when you really think about it, and that's do not perform any unauthorized experiments. Now, why do you think that's so? Why you don't want to perform any unauthorized experiments?
Because some of the experiments, you don't know what you're doing, they might cause like
outcome.
Yeah, I mean, and not only that, I mean, they have your equipment, so if the lab teacher or whatever don't give you permission to do any experiment, don't go and do your own experiment, because the liability of that experiment the results or whatever happened would be on your own. It would be your own fault because they'd say, well, I didn't tell you to do that. So if you go in the lab on your own, start mixing stuff, and you end up burning yourself, you end up, mixing stuff you shouldn't be burning, making chemicals you shouldn't make, and you end up harming yourself or harming someone else, the school, you can't take no liability for that. It's on you because you did it unauthorized. Like, you didn't have no permission to do it. You sneak and you did it. And so it's on you. So you don't want to do something that's not authorized. You want to do something that they give you permission to do. So make sure whatever experiments that you're doing, make sure that you are given permission to do it by the person who know what they're doing. Okay. Number 2, and this is close to the first one, and that's never work in the lab alone. Okay, never work in the lab alone. Why do you think that we shouldn't work in the lab alone? What's the rationale behind that?
So you have someone to call to help if something happens?
Yeah. So you have someone to call to help. Anyone else? Why shouldn't you work in a lab alone?
You might have someone to tell you when you're wrong.
Someone to tell you when you're wrong, yes. 2 heads are better than one. Also, if you end up smelling something inside something and that end up knocking you out, at least someone is there to, call for help, run for emergency, and stuff like that. Okay, so you want to always have someone working with you, and also as a witness too. You know what I mean? So if something happened, you could be like, okay, um, both of us were here, and they could testify that, hey, um, this was an accident, or it wasn't intentional or whatever. So that's also true. The next one, someone said this before, playing and running are forbidden, right? Are forbidden in the lab. All right, so you don't want to play and run around in the lab. And what is the rationale behind that?
You're liable to knock something over.
Yeah, you're liable to knock something over. You're dealing with, listen to me carefully. The most detrimental things that could happen is inside a lab. Inside the lab, you don't know what those things are and what could happen when they on your skin and whatever, right? Chemistry and physics and all those different things, they are dangerous things to play with, right? You want to make sure that you suit up, well geared, when you're dealing with these things and nothing to play with, right? And so you want to make sure that while you are doing your science thing, that you yourself don't get harmed, because if your face get all soiled from that acid, it's only going to be you yourself and you walking around with a face that is acidified, right? And you don't want that to happen. So make sure that you protect yourself, make sure that you are well covered, make sure your eyes don't be seeing flashing light like that, so you wouldn't end up getting blind or, any tragic thing happen. Make sure you protect yourself first, because when the experiments are over and everybody put away their capes and everybody stop being scientists, you have the real world to face, and people are not gonna be forgiving and say, "Oh, that's so sad. Oh, no, 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 no." They're gonna tease you and they're gonna make fun of you, regardless of how you got that injury. So make sure you don't get no injuries in the lab. So report all accidents to your teacher immediately. All right.
But Mr. Petit, I know it sounds stupid, right? But all accidents that happen in the lab happen in the lab.
All accidents that happen in the lab happen in the lab. I don't understand what you mean.
Like accidents could still happen.
Yeah, accidents still could happen. You mean for number 4, or are you talking about number 3? Which one?
No, I mean just in general, even with the lab rules, like.
Yeah, I mean even with lab rules, accidents still could happen. The aim of these rules is just to try to mitigate as much as possible, those accidents from happening. But accidents are accidents, and by definition, they are, surprising and they are not intentional. So, but you try to mitigate them as much as possible, and one of the ways you can mitigate them is by not doing silly things. And so that's the thing. So make sure if an accident were to happen, report it to the teacher immediately. Like don't try to hide it, don't try to cover it up. Let the teacher know what's happening. Be transparent. Okay. Use it. Use. No, let's just write this one instead. Wear protective clothing when performing experiments with chemicals. So if you have experiment that deals with chemicals, make sure wear your protective clothing. All right. So these include chemical. Oh, I should really have this written like this so it could be in one moment. Okay, so these include chemical splash goggles. So not the goggles you go diving with, right? Not them. Apron or lab coat. Anyone have a lab coat? Lab coats. And rubber gloves.
Sadly, no.
Sadly, no. At our school they make that mandatory. And like that's a part of your grade. And the lab coat.
Wow.
Yeah. The lab coat, the students look so good in them. The lab coat have the school name on it, the embroidered onto it.
What school that is?
Oh, I thought you had to buy it.
You had to buy it, of course. You had to buy it now. It's New Horizon Academy. They really look nice. I really like how my students look in their lab coats. They look so sciencey, and so
they look like the future.
Yeah, they look really sciencey. They look, even though they don't know a lick of science like that, but at least they look like they know what they're doing. But it's just a thing. It's one thing when you outfit for the task at hand, it really makes it memorable and everything. So tie back long hair and remove ties when performing experiments. Okay, so I'm going to tie back long hair and remove ties when performing experiments. That's what Kennedy talked about.
Yep.
Okay. So this one is very important. We used to break this all the time when we was inside our chemistry lab. But never eat, drink, or chew gum in the lab. All right, so don't eat and drink and chew in the lab. It's not a cafeteria. Okay. Number 9. Number 8. This is sort of less obvious, but always add acid to water when mixing an acid with water.
So that's when you're diluting the acid, right?
Say it again.
When you're diluting the acid.
Yeah. Add the acid to the water. Okay. Now, what happens if you add the water to the acid?
It erupts.
It could it could cause a mist of corrosive fumes. All right, so if you
Okay.
if you add water to acid, this could cause a mist of corrosive fumes, and we don't want corrosive fumes. We don't want to be inhaling any corrosive fumes. Okay, so okay, so so add acid to water. The next thing is
Are the fumes visible?
sometimes depending on how much you put, right? Number 9, discard unused chemicals that you have been working with, and you don't want no one to mistake any solution for Kool-Aid or for Tampico or whatever, right? And end up drinking it. So anything that you have left over, and you want leaving it later for observation or whatever, just discard it, right? So discard properly now any unused chemicals that you've been working with, okay? And of course, never pour them. This is a good one. Never pour them back into the storage bottles. Why not? Why you don't want to pour them back into the storage bottles?
Maybe because you don't know what they react with.
Yeah.
Mixing too much substances.
Say it again.
Mixing too much substances.
Yeah, like I mean, if you have a solution, and if you have a solution, right, and then you already mix that with some other chemicals, and you say, well, it still look the same, and let's just kind of save this for later, right? When you try to save it for later, what happens is, or you try to put it back inside the same container it was, it's going to contaminate the pure ones. And so when you go to do another experiment, and you go to try to test to see the properties of that particular solution, it's not gonna react properly. Okay, so it says they will contaminate the stock supply. Right, so that's why we don't want to pour them back into storage. They will contaminate the storage supply. So the next one have to do with heat. Never point a test tube that you are heating at someone. Alright, so don't point no hot test tube to anyone. Alright, you don't want to get them, you don't want them to be, you don't want them to get burned or anything. So don't point nothing hot to anyone. Now what happened if you end up, spilling over something, bad or dangerous on your hand?
Get burned your skin.
You get a rash.
I mean, like, what would you do? Like, what would you do? What is like the immediate thing to do?
Throw it in water.
Put it in water.
Yeah, try to rinse your hand out quickly in water. So if you spill an acid or other corrosive chemical on your skin, if you do that, don't panic. Sorry, on your skin. If you do that, do not panic, right? All you need to do is wash it out Wash it at once with large amounts of cold water. Right? Okay, so those are the. Oh, we still have more. That we have some more. We chose it. So let's consider these other ones. So we still have more time. So this one is straightforward. You don't want to be tasting nothing. Okay. So never taste or touch chemicals unless you're instructed to do so. Why? What's the rationale behind that?
You don't want to taste the wrong thing because you could probably mess up your gums or teeth.
Yes, yes.
What
Yeah.
might be poisonous?
What might be poisonous? Good. So some apparently harmless. So it could appear as it's harmless, saying it do nothing to you. But some apparently harmless things are very dangerous, right? So some apparently harmless chemicals may be poisonous or cause skin irritations. Number 13, do not handle flammable liquids near the what? You don't want to, oh sorry, I spelled poisonous wrong. You don't want to handle flammable liquids near what?
The Bunsen burner.
Near the Bunsen burner or near an open flame. Okay, you don't want to cause a fire because it can cause a fire. So just some other things you want to have a first aid kit in the lab. Anyone know what a first aid kit is?
Something has a bunch of treatments.
Yeah, it's an emergency healthcare kit that is used to give quick assistance to persons with minor injuries. And then we have a fire extinguisher.
You don't think this list too long?
The list of rules?
Yeah.
I actually cut down. It's more. I just, it's not long. It's I mean, some things go without saying, but you just want to say it just to cover the bases. All right. But anyway, a fire extinguisher is a device. Of course, that we use to put out fires. All right, now there are certain danger symbols that we have, right? And these symbols, they tell us what by looking at them and if it's on a chemical, we know that there's a problem with the chemical and we know the specific problem. So sometimes we may have a a substance that is flammable. So let me just go on danger symbols so we can just get a basic overview of it. Okay, let's do in science. So, okay, good. This is a very good one. So these are the different danger symbols. So let's put it right now. All right, so this symbol means that if you see this on something, that means that it's explosive. All right. If you see this on something, that means it's flammable. Now, when we say flammable, what do we mean?
It will cause a fire.
Yeah, flammable means can cause fire. Here we have, this one is toxic or actually poison. Okay. And what that means, it can cause illness or death. Is this saying any corrosive? Yeah, corrosive. This is a symbol for corrosive. You see, if you drip it, it burns the skin. You see that? You see that, right?
That's all.
Right. So corrosive means it can cause burn
or go for the skin.
or skin irritations. Okay, or it can eat away the flesh. All right. So this one means it can be dangerous for the environment. This one means that it's harmful, highly flammable, toxic, an irritant, and very, very toxic. Okay. All right. So it's 8:30 already. I don't
Not
know.
an oxidizing one, man.
Oxidizing. That has something to do with oxidation. I don't know clearly. I don't know what that means.
I guess maybe because oxygen level is high, so high chance of flash fire or something.
I don't know. I have no idea what this. I know oxidizing has something to do with oxidation, but those ideas I can't remember clearly anyway. So I'll have to look into that for you. Alright, sure.
8:30 already. No.
Yeah, it's 8:30. I don't know. Oh yeah, I just remember my time. My time is wrong. So this doesn't mean what it's saying. It's
No problem.
all right. Okay, so it's time for health science, right, Miss Cooper?
That sign was supposed to be over, but okay.
Okay, so the last thing we was on. What was the last thing we was on in health science anyway?
Berries on deficiency diseases.
Oh, we was on deficiency diseases.
Very.
We haven't finished
What's
this.
the last one?
Oh, so that was the last deficiency disease. Okay.
Yes.
And then I asked you for homework to do. Tell me the different populations that has the different populations that have the highest amount of these diseases, right? I told you to choose like 4 or something like that.
Elizabeth D.
Yes, sir.
You can go back on the notes, please. And you write one more thing.
Which one here?
Yes, sir.
That's Nathan.
Yes, sir.
You should be in our math classes. Why don't you come to our math classes?
I already have math classes.
We already have math class. Oh, okay.
Every Friday.
Every Friday? That's
Yes,
it?
sir. Sometimes, but Tuesdays and Thursdays. Well, no, Tuesday, Thursdays, Fridays, yeah.
That's it?
Yeah. Then I get social studies.
When you have social studies?
Monday, Tuesday, Wednesday.
Oh, okay, so you book right out. Alright. But it would have been good to have you in our math classes.
Mine ain't my subject.
Yeah, that's why you need to come. Yeah, don't worry. Don't the other students will tell you. It'll be so easy, they just don't know what to do. That's how easy it be.
Even a baby could do it.
Ain't even a baby.
Never.
Even a baby could do it. That's how much formulas we have. Ah.
I don't do that. I don't like algebra, bro.
Yeah. But we're being sarcastic, to be honest. We have some rigor to it. But all in all, it'll still be okay. I want to deal with the topic for today. So we talked about hereditary diseases. That's one class of diseases. Then we talk about deficiency diseases. That's another class of diseases. There's at least two more classes of diseases. Can you think of another category of disease that we haven't talked about in depth? Pathogenic diseases, yes. All right, diseases that are caused by some sort of bacteria or whatever, right?
Fungi.
Yeah. So that's the topic, pathogenic diseases. Now, which one do you think is worse? Deficiency, hereditary, or pathogenic?
I think pathogenic.
Pathogenic sounds deadly.
Or hereditary.
Boy, this is a tough one. This is a tough one. I will be honest. This is a tough one.
Well,
if we was living inside a bubble where the pathogens wouldn't affect us, then hereditary would be the worst. Because against it.
I mean, hereditary is still bad though, you know. And the thing about hereditary is that hereditary is like, you know, the chances of you getting a solve is very low. Pathogens, we could deal with pathogens. I mean, you know, we've been dealing with them for a pretty long time. But pathogens also are deadly too. And in fact, we are dealing with a pathogen. You know, we're talking about corona. So you know, it's still a problem, but I would say between hereditary and pathogenic, they would be the most problematic ones. But these are diseases caused by other living organisms, such as bacteria, fungi, viruses, worms, and protozoan or protists. And that's just basically a single cell, so protist as a single cell organism. All right. Now this when these pathogens, right? When these pathogens are carried into the body, we call them by a specific name. Okay. So when pathogens are carried, anyone know what the name that we call them when they carry it in the body?
Germs.
Say it again.
You mean germs?
Okay, let me put it like this. I should say it like this. When it's okay. How should I put this? When it is carried about by when we have these pathogens that are carried about by other animals, what are those animals called?
Species.
And then host?
No.
I don't really understand what you're asking.
We have pathogens, right?
Yeah, we have pathogens.
Now, when pathogens are carried by other animals, what do we call those animals?
Host?
And so
I mean, I ain't really looking for hosts. I'm looking for something else.
Victims.
Okay, a disease-carrying animal.
Oh, I know what you mean now.
Yeah, what is that? What is it called?
Tip of my tongue, I can't remember.
Back then?
Say it again. Someone said it.
Didn't they say infected?
No, they didn't say infected. They said something else. It's a V word.
Vectors?
Vectors, yeah.
Model?
As factors. For example,
Come on, this health science or physics?
No, it is not science. I know you have vectors in physics. They're not the same vectors. The vectors in physics are the one that has magnitude and direction. Okay? But
Scalar or quantity?
Well, if it's a vector, it can't be scalar, right? Okay, so because scalar only has size, stuff like speed and, stuff like height and volume, those are scalar quantities. But vector quantities would be stuff like, displacement and velocity, stuff like that. Okay, so for example, a mosquito does not make a person sick, contrary to popular opinion. But how does a mosquito?
Dengue.
Instead, what do? They are vectors. What do they do? A pathogen, instead of pathogen.
They spread diseases.
Yeah, exactly. Which lives in the mosquito. Right, which is a parasite to the animal.
That's something similar to like rabies. Then.
Yeah. Parasite to the animal causes the illness. Okay. So don't blame our nice mosquitoes, right? They can't help themselves.
I'm back by some right now.
Yeah. There are many types of animal vectors, such as we know mosquitoes, rats, flies, and guess what? Even humans. Yeah. And many more. Pardon?
So never mind.
We can be a vector when we have what? A pathogen.
Pathogen.
And we carry that around and spread it. Okay? Okay.
I know this is kind of maybe like a little out there, right? But why is pathogen so smart?
Why they so? I wouldn't say it like that. It's more like You ever tried to? And this might sound weird, right? But you ever tried to kill a rat or mosquito? Not mosquito, a rat or a cockroach. Like
No, I never would.
You never tried to kill
I kill cockroach all day.
All day. But like, if you throw them in water, right? They just try. If you ever do this, if you throw them in water, they just try their best to kind of jump.
Yeah.
No, but no rat.
And
yeah,
and
kill rat like that.
Yeah.
Yes. Try to get it.
If you are not smart, they could outsmart you. Now, it's not them being smart, it's just them trying to survive. You understand what I mean? So it's not that, oh, this rat's so smart, da, da, da. No. The rat is on the tip of survival. He's gonna do whatever he could do to survive. So when we use the word like they smart or they cunning or it's not really them trying to use tricks. They just trying to survive and they trying to get out of the hot seat. So whatever they could do to keep living,
sentient.
they will do. You know what I mean? And so the same thing with these pathogens. Whatever they could do to continue their survival, they will do. And so that's why they are sometimes so hard to kill. Okay. Okay, and so they're late to deal with. All right, so the treatments, but the good thing is that they're usually treatable as a general rule. The treatments for different, and that's why I kind of, I kind of have some more sympathy with the pathogenic diseases, because all of us had pathogenic diseases in some sense before, because all of us have had the flu, all right, before, and so that's a pathogenic disease, and so
hereditary worse.
So yeah, hereditary is worse in a sense that, I mean, it's it's rare that you have the treatment for it, because I mean it's hereditary, so you can't change it. I mean, as a general rule, so it does have a very, that's why hereditary to me is like, that's a life sentence almost, unless it's a miracle or something like that. So treatment. Yes.
Like if your family like have diabetes, right? And you could like if you know that they have diabetes, you could like try not to eat stuff like what could cause you to get it or something, right?
Yeah, you could do that. Like they always say, genetics pulls the gun. Sorry, genetic loads the gun, but lifestyle pulls the trigger. That means that you could have a genetic disposition towards diabetes, but if you try to eat healthy, try to watch your weight, you could end up turning the tide, and that could happen. But in all cases that don't happen, what I mean is that for certain genetic diseases, like you can't eat your way, you can't lettuce your way, you cannot kale your way, you cannot broccoli yourself away out of certain things. Certain things are just fixed. You know what I mean? Like, you have some people, everybody in their family tall, right? What they gonna be? You think they're gonna be short? They gonna be tall. Like, there's none that they could do like that in their genes. You know what I mean? There's some people who very short, like they have you have giantism, and you have
Yeah, some people who ain't got a maths in their family, so
no. That one is treatable. All right, but yeah, the treatments for different pathogenic disease vary according to what it is caused by, Okay, and the good thing about pathogenic disease is that you usually could prevent yourself from getting them as a general rule. So prevention of pathogenic diseases, just gotta be clean. That's it. Caused by worms. So we have certain pathogenic diseases that's caused by worms. For example, worms in pigs. And you could prevent yourself from getting those pathogens that are caused by worms in pigs simply by doing what?
cooking it well.
Ah, boy, no, no. How could you prevent from getting it, right?
What would you eat?
Well, since you go on that diet action, you can take it out your diet.
Okay, yeah, you could take it out your diet, right? Like, hashtag be a vegan. Just saying. But just saying.
It'll take me a while.
All right, let me go by the book say. So the book say, I guess this person still is eat they meat. So they said could be as simple as cooking foods. Yeah. Since y'all want to hear that properly.
And that's what I say. I just cook it good.
I don't agree with that. I disagree.
Why?
Because you never could really cook out a worm, really. You know what I mean? I mean, what you gonna cook it till it die? Like, how do you know when it die all the way? Like, I mean,
Science can tell us.
Microscope.
You used to tell me. So for every pepperoni, you just put it under the telescope to make sure no worms in there. Never.
Nah, I ain't never that.
Exactly.
What?
Exactly. So, but anyway, they say that you could prevent yourself from getting it. Of course, cooking it does help. Cooking it well does help. I could be honest, but you can never be certain. So with every bite is a risk. All right. So that's just life. I mean, that's just one of the things you get from choosing to eat those things. Or you could avoid them altogether. Anyway, prevention of
And all of them come out the ground. See them ground in the tree.
pathogenic. No, but they're worse. Them worse. Pathogenic prevention diseases caused by worms could be something else. For the washing one's hands, right?
I'd be more afraid of these greens now. All them pesticides and things they.
Yeah, come on, you're a scientist, man. Come on. Remember the term biomagnification? The higher up the food chain you go, the greater the amount of poison or toxin.
Based off how they doing things, every day, nothing there is safe as it
No,
should be.
I understand, but I already told you the case, right? The higher up the food chain you go, the greater the toxin. That's biomagnification.
Yeah, the things we important, they ain't really regulated as they should be. So.
Washing one's hands. So that means just eat everything and die. Eat anything and die.
Yeah, just play the hand we get.
No, you try to do optimization. That is, try to eat the best of what you could. Right? That's what you do. Anyway, washing one's hands after using the bathroom. Yeah, and I was somewhere and I was using the men's restroom, and someone was walking out. They came out the stall and they walked right out, trying to walk right out. I said, hey, bro, wash your hands. He's like, he started telling me.
He ain't look at you crazy.
Yes, he did. I was like, bro, wash your hands. And he's like, boy, when you home, what you do? Do you wash it? I was like, bro, this is. I ain't gonna tell you the location, because that'll be embarrassment. But
why not?
This is. I was like, come on, man, when you home, So, yeah, wash your hands, men, especially the men. Wash your hands, right? After using the restroom.
I sanitize my hands.
No, wash the hands.
Telling you.
Nah, you gotta wash your hand because
I wash it after I eat because I don't touch my face.
Wash your hands, please. When you
hey, Mr. Petit.
Yes, sir.
You just so do you trying to say the man just sit in the toilet and just wipe his hip and he ain't wash his hand? That's disgusting, bro.
It is disgusting, right? So make sure wash your hands after every use. Once you step in that restroom, wash your hand. Don't leave. Even if you don't do nothing, wash your hand just as the demonstration. You know what I mean? Let people know that's a good thing to do.
Just as a habit.
Just as a habit, All right. By practicing good hygiene, such as what? Covering in the nose, right? And mouth when coughing. Because those are the ways that pathogens are spread, right? Okay, so
yes, sir.
Yeah, they always pile up random areas. They so cunning.
Yeah, covering the nose and mouth when coughing or sneezing, right? I don't know. We losing these simple, social etiquettes, right? People coughing and sneezing willy-nilly. They wouldn't cover their mouths. They wouldn't, that ain't good. Even before the coronavirus. I mean, we need the coronavirus to tell us wash our hands. You know what I mean?
It's so.
I think that we used to do it more before COVID come out.
No, I feel like people just start getting sanitization because of COVID.
No, I feel like they mean it not to do it.
Practicing good hygiene, such as
The fastest I ever see hand sanitizer go.
and coughing. Some people didn't even know what hand sanitizer was before COVID.
Never.
Nah.
I don't know where they living in.
I telling you, okay.
So they ain't expect. Wait, what? Hold on. How does this make sense?
I mean, You don't commonly use sanitizers daily.
No.
In the first
Like
place.
hand soap for the
So
bathroom.
they never see sanitizer in their life. So they never see soap then.
I mean, they saw soap now. We ain't go that deep, but um, hand sanitizer is usually something that you find at establishment, not really at homes. Not until COVID came, and you see them more in homes and more in people, persons, and stuff like that. Okay, so let's read this. It says that the treatment for different pathogenic diseases vary according to what it is caused by. But prevention of pathogenic diseases that are caused by worms could be prevented by what? Simply cooking or properly washing one's hands after using the bathroom. Practicing good hygiene, right? Such as covering the nose and mouth when coughing or sneezing could stop someone else from catching influenza caused by virus. So if you
Or
are
wearing a mask.
pardon?
Wearing a mask.
Wearing a mask. I mean, wearing a mask could help in some sense, right? But this book wasn't written in COVID-19 the time, so
I mean, you in some Asian countries say when they sick they just wear a mask in the first place.
okay.
Mask wasn't that popular.
No, it
Before
wasn't.
COVID.
No, it wasn't.
People think it was crazy.
They do that because they have more respect for another human being.
Now, all sexually transmitted. So you have certain pathogens that are sexually transmitted, and there's an easy way to avoid those ones, right? Just don't what? Just be abstinent.
Just be abstinent.
So all sexually transmitted diseases are caused by pathogens. So those that develop from a bacteria. It's important to know where these things come from. So the ones that are from bacteria, this is not from a virus, this is from bacteria, are going to be your syphilis. Please remember that. They like to ask questions like this. Syphilis is caused by a bacteria, not a virus. All right? Or gonorrhea. Okay? And this is a sexually transmitted disease.
AIDS.
Now, AIDS is caused by a virus. Okay? So it may be cured. How can we cure this thing? And treated by, they say in this book, an antibiotic. All right. So using antibiotic, according to the source, they're saying that it could be cured or treated. Okay, and there's others. Okay, let's develop a chart. You know how we like to start our charts. So we're gonna develop a chart. Oh. You mean all as in yes, or all as in what?
This is the most charts I ever draw.
The most charts you ever draw? Yeah, right. Y'all stay drawing charts in class.
Nope.
Nope.
I know.
They just do like bullet points. They don't really draw like.
We just write notes, bro.
That is
Yeah.
right notes.
We just write a bunch of notes.
That's it.
Yeah.
Yes.
We drawing charts.
Maybe if it's outside, draw a diagram and label it out your head. That's I don't know. That's how I learn.
All right. So let's say we have a bacteria. An example of this would be salmonella. Oh, salmonella. The effect on the body. So that's when you get like food poisoning. Right? So food poisoning, and is spread by what? By water or food contamination. contaminated with, be careful, fecal matter. Okay, so if you have you know, persons are not being really you know, they go inside the bathroom, they don't really, you know, deal with their hands properly or whatever, or you know, the fecal matter of animals end up in the water or the food, and you go ahead and eat that, you know, it's not gonna be nice.
As of date, don't they use fecal matter as fertilizers for plants?
Yeah, but the good thing about that is that you know, by the time that thing break down and you know, absorbed by the roots, it's transformed, you know, so it's the tree know how to, you know, convert it into a useful form such that it's not harmful to us. But raw like that,
So,
you know.
would it be a stretch to say that you eat fecal matter
Um,
from the plant's ovary?
I mean, it wouldn't be a scratch. I would understand what you mean, but you know, the plants are good for us. They God placed them in as a good cleanser for us to help us out.
And then they say that's how we got our atmosphere in the first place, to be livable for us.
The thing about it is
From
that
the plants.
the plants are really good, man. I mean, the more I look at it, I like wow, especially when it comes to photosynthesis. You know, that's why when you know have a lot of people cutting down trees, um, that's not good. You know, cutting down trees for the sake of you know resorts and stuff. What will happen if you have the last tree? You know, I saw a picture where they had um the last tree. You know, there's given the there's given an illustration where they did so much cutting till they reached to the last tree, and you know, there's this guy. He is he had an oxygen, you know, them face masks, and he tied it. He had it attached to the tree, and he said, "Dear nature, we're sorry." And that's how the
Ah, my. I think at that point we will have replacements for trees.
you think so? I mean, you know, they
Yeah, we will have replacements for trees.
I understand, but nature is nature, man. It's
All that's nature. You forget energy can't be destroyed.
I mean, you know, trees provide more than just oxygen, man. Trees provide a sense of comfort, a sense of beauty, you know, a sense of
Shelter.
shelter. You know, it's more than just the
Think
oxygen.
that in the future
You
we
know,
could be 3D printing this
you know,
yam and thing like it's that.
commonly referred to as flu. This virus has been all right, commonly referred to as flu. This virus has been a pandemic many times, causing the death of 40 million 40 million people during 1918. Another virus, so this is another virus here, is going to be, whoa, it's 9:02. I'm so sorry. I'm so sorry. I am so
No, that's no
sorry.
problem.
All right, let's do the last one. Hepatitis. That's me talking about trees and stuff. Sorry about that. Hepatitis A, B, C, and D.
Oh no, the whole alphabet.
All right. This causes swelling and malfunctioning of the liver. Now, symptoms would include jaundice, that's the yellowing of the eye and skin, joint pains, and daily vomiting. Okay. All right, so that.
I always had this question.
Go ahead.
How hepatitis B starts? I don't know what caused it.
It's a virus that causes it. Right now, how they get it? I think hepatitis is a sexually transmitted disease. Let me see.
I think what she asking is like how the first person get AIDS, like that.
Oh, you mean like that? No, I don't know. I don't know. Probably made that in a lab. You know how they go. Um, yeah. Yeah, it is a sexually transmitted disease. I don't know how it initially, I don't know its origins, but yeah. Okay, so that brings us to the end of.
I always thought I was like some type of joint.
You always thought it's some type of what?
Joint pain because of them medical commercials.
Oh, okay. Yeah. All right, so if you're done, make sure please send in the.
I have a question.
Go ahead,
See you
sir.
later, Mr. Tate.
All right, have a good one.
I think you made a typo error.
Say it again.
I said, I think you made a typo error.
Where?
And influenza, the effect on the body when you go
Commonly referred
pandemic.
this virus has been a pandemic many times, causing. Yeah, I have a typo. Causing the death, right?
Yeah.
Causing the death of 40 million people. Okay.
Elizabeth, you ever heard about Kurt Kazat?
Kurt Kazat? No, I don't know that.
On the YouTube in a nutshell.
No. Wait, let me end the recording. So, all right.